Hey math kids, today we're going to compare linear, exponential, and quadratic functions in a couple different ways. So the first thing is we're going to go to Desmos. We're going to graph these three functions. So y equals x squared, and y equals 2x. And so let's look at those like this. So we see that the red one is linear. We see that the blue one is quadratic, and we see that the green one is exponential. So if we zoom in about right there, and we compare the slopes. So notice that the red slope covers about one box for every one box it goes up. It goes one box over. So it has a slope of 1. Now if we look at just this same box for the blue one, it covers the same amount of distance. It goes down one box and right one box. So the average rate of change would be about -1, but it covers the same distance, so we consider them to be both just as steep as each other. Now if we look at the green one right here, we see that it only covers about half a box for every one box it goes over. So in this case, like early on, the exponential function has the smallest slope. Okay, whoops. So if we look to the next box, let me get the zoom the right way. There we go. The red one still has a slope of 1. That's not going to change because it's linear. The blue one ends up having about the same. So the average rate of change on that is going to be about 1 as well. So those have about the same slope. And then the green one now covers about one box for every one box over. And so in this block right here, they have about a slope of 1. Okay. Now, if we move up here, zoom into that. Okay, now the green one, it rises 1, runs 1/2. The blue one rises 1 and runs a very little amount. So the blue one is climbing pretty quick. Then the red one still has 1. Now, the blue one is going to continue being steeper than the green one until they cross up here somewhere, right here. So they cross about right there, and now the green one's going to pull ahead. And so if we look at it, and we keep going, and we keep going, and we go up here, we're going to see that the green one is going to keep getting steeper and steeper and steeper, and that is a characteristic of exponential functions. So exponential will eventually become the steepest every time. So if we're comparing linear, which is the red one, quadratic, which is the blue one, and exponential, exponentials will always become the steepest in the end, even if they don't start out that way. Okay, now I'm going to look at these tables, and we want to identify what type of function it is. So right here, see how we're adding 1 each time to go through this? That's a characteristic of a linear function. Okay, right here, we go from here to here, it's multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2. Actually, this should be a 1. I messed up on the table, sorry. That should be a 1. And that's, since we're multiplying by the same number over and over, that's going to be exponential. Okay? Now this one's a little bit different because we, let's see, we can think of it like we're adding 1, adding 3, adding 5, adding 7, adding 9, and so the secondary addition would be to add 2, that makes sense. If we take the numbers we're adding and then we see how much we're adding again, it'd be 2 each time. If that situation happens, it's quadratic. Another way we could see is if we take this and we square it, that's all that's going on. So this is quadratic. Okay? So in the table, eventually if we go further, this would start to become large very quickly, because we know eventually exponentials get larger and larger and larger, quicker and quicker and quicker. Okay? Now, what we're going to do, we're going to do an example problem where we graph 3 to the x as well as x cubed, and zoom out, zoom in a little bit. Okay, that's probably good right there. Now it says use your graphing utility to graph these two. We did that on the same pair of axes. Please compare the rate of change of each graph on the following intervals. So the first one is from -1 to 0. So if we're looking at our slope right here, we just want to compare which one has a steeper slope. Well, for going across 1, we only, if we count these, we have 1, 2, 3, 4, 5 boxes, and we cover about 1, 2, 3 and a half. So for one time going over, we only cover about half as much height, or 3.5 height. Over here, for going over 1, we rise 1 as well, and so that means that this black function has a steeper slope than the purple one. So for this one, we would say x to the third is steeper for 3 to the x on the interval. So the interval would look like this. Whoops. Okay, don't worry about this, but for the first interval, we would say black is steeper. Okay? And we're going to look at this other interval from 0 to 1. Or let's just say black has larger slope. Okay? Probably don't need that. Okay. Now, on the next one, we're looking from 0 to 1. So from 0 to 1, we go over 1, climb about 1. Now, alright, I'm having a hard time with this. There we go. Over here, it takes us much less time to climb all the way up to 1. So we only go over about halfway, and we climb 1. So that means that purple has larger slope. And if we look from 1 to 2, we can see for 1 going up, we only go over 1 and about a half. And for going up 1, we go, it takes us a little bit longer to do that. So the black starts becoming steeper on that next one. Now if we went really far, we know that the purple is going to be the steepest eventually. So we can see that starts to happen right there, and that's just how those functions work. So if you need additional help, please come to Math Lab. Until then, calculator.